And we're back. Hello there. Welcome back for more Advent of Code. So tonight I want to take a look at what we did earlier for day 3 because this solution is, well, quite chunky, and it's basically how it came first time. But I think there's quite a few things that we could probably refactor to make it a bit more expressive, I guess, more readable. But before that, I think I want to commit what we have, just to have a base working solution, and then we can compare what we do to that. So let's say add a rough first. A rough solution for day 3. Sorry, I was thinking there how to word that message, but that's fine. Okay, so there's quite a bit of code here, but I think I also want to remember what we did. My cell phone is ringing a lot. Let's put this in not disturb. Okay. So we had the code for part 1 is all of these nested loops. Beautiful. And then for part 2, we added this getAllNumbers function that returns all the numbers that appear on this grid, 467, 114, etc. As a number already, and I don't remember the order of these things. Yes, the XY coordinate where they appear and how long the number is on the grid. So with that, the solution for part 2 was relatively straightforward. The first thing we do with this information here is to store in a hash map all of the XY values of those numbers and which number they correspond to. And then we iterate the grid with these nested for loops and find all the gears and count how many neighboring numbers are for each gear, and if there are 2 neighboring numbers, we multiply those 2 numbers together. So I'm pretty happy with this code for part 2. I think it is quite all right. Look at my cat there on the background. She sometimes does that, really attacks that pillar. But yeah, the idea of this function was also that it might be useful for part 1, and I think that's the first thing that I want to try. So in part 1, we have basically these 2 first loops that are also iterating through the grid, and it's basically doing this work of recognizing each number, and basically all of this up to here is same logic as this getAllNumbers function, and then the only custom part is this Boolean expression here. If it is a part number, which is something related to the problem here, it is a part number if the number itself touches one of these symbols. So this would be a part number, but this 58 is not because it's surrounded by dots. And yeah, that's it. I think this should be easy to replace with a call to this getAllNumbers function. So let's try to do that. Even before that, there is this engine grid variable that I find a bit verbose. Let's call it just grid. And here too. Well, and here too. Okay, that's better. And that also collapsed this long condition. That's good. No more engines in the code, okay. So how would we do this? We have this sum. I think, okay, get all numbers for this grid. I think we could even express this as directly with iterators. So let's say, let's sum, this is actually not just any sum. Let's call it, oh, look at this. We have more of the drawing of this floating island thingy. Awesome. What is it that we were calculating in part 1? What is the sum of all the part numbers in the engine schematic? Yeah, okay. So part numbers sum. Yeah. So we can say get all numbers for this grid. And then we want to filter the numbers that are part numbers. And then, yeah, get their like the numeric part of those and sum them all up. So let's say filter. Oh, this is not an iterator. Actually, for that, let's extract this into a variable and call this thing. I'm not sure about this get all numbers name and things, but let's keep it as that. We're gonna filter by a predicate that we can even extract right away called is part number. Right? Yeah. Let's. Well, this actually. Well, we need an iterator here, but this iterator iterates over like tuples of many things. What's your problem here? Like this is a vector of these things, not very nice to look at. Like I would love it if but I think Rust doesn't have syntax for this. To say like, hey, this is a tuple and say is part number and just like splat this. Well, no, this is the reference operator, but imagine like you could splat a tuple as arguments. I would really like that, but I don't think that there is syntax for that. So this is a number and we had x, y, and length, right? Which is, yeah, it's all right. I want something else here. No, I think this is fine. So, and filter gives us an extra in direction. So let's calculate that and let's just pass the same things here. Length. Then after filtering, we're gonna map these things and we are going to only care about the number actually. So n and well, what do we want to do? Actually, let's just take the we could not name any of the others and just map to the number n, I guess, and then sum all of this. So you don't like this because, oh, I need to close this. This is not very pretty. Let's just grab the tuple and say tuple 0. It's not great either, but it's fine. Oops, I hit control comma instead of control dot. Generate function. Great. Let's call this thing num and num length, and this is basically this condition here, I think. My cat is occupying the mousepad and interfering with the mouse. So if I remember correctly, this is the function. Oh, it also needs the grid, of course. Yeah, because it needs information in the grid. So let's take the grid, which I don't know if I should type alias for this thing. The add function, I think that add function is something that could live as well, as a top level function, because we are also repeating that add definition in a couple of places. So let's simply call it add also. It's going to take these two things, x, y, and the grid of this type, and it's just going to say this. And your problem is that this should return a byte. I mean, maybe this function could be inlined everywhere, but let's say, okay, add this and this, and grid, and grid. Okay. Equals a. Sure. I can avoid this repetition, but let's leave the repetition there. So this thing is part number, also needs the grid here, and you're complaining because arguments to this function are incorrect, because these things are two levels of indirections. Not very pretty, this double dereference here, but it makes it work, so let's leave it. These are like primitives, so it's fine. Okay, and is this all the, is this parts number sum the same as this sum? Let's see, part numbers sum. Oh, but why does this all numbers? Let's go to the function. I'm not sure where I screwed up, but yeah, we can iterate this like this, I think. Yeah, you can consume it if you want. Oh yes, the sum also needs a type, which I guess is U32. Yes, it is. Okay, so it seems like it worked. And now this little thing is equivalent to all of this. That's great. Goodbye. So we have the part numbers sum and the gear ratios sum, I guess, to be consistent. Yeah, gear ratios sum, right? Let's print both things on the same line as we did with previous days. This, oh, is part number doesn't need the number itself. Okay, huh. I wonder, Simone, My cat is really insistent today. Yeah, because it doesn't need the value of the number itself. It just needs to know its length. Yeah, sure. So let's not pass the number itself. We can do something like that. All right. And was there some sort of syntax for, like, I only want the number, but I don't want anything else? How was the syntax for this? Rest. I don't remember. I seem to recall that there was some kind of syntax. Rust tuple structuring. Deconstructing. Deconstructing tuples. Yes, this. Just 2 dots. Doesn't conflict with syntax for. Yeah, that's great. For the syntax for ranges. Okay, so now the add closure here is not used. That's awesome. Great. I also. So yeah, this is already quite nice. Now we are. My cat is insisting in getting to my lap, so I will leave her there. So. What was I thinking? I was thinking that this is alright. At least for part 1. Part 2 could have, I guess, a bit more love. But converting, like for instance, converting these nested loops into iterator code, it's not really, it won't make things more readable. I know that I have already done that sort of transformation, because you could like get the same iterators as this that we're using here, but combine them, like say, okay, do a flat map of the things that these things return, and this return the sums for each row and things like that. But it's just a nested mess of the same nestedness of the loops, or even more, and it doesn't make things more readable, in my opinion. So I think this is fine to have this variable numbers by x, y is also fine. Maybe the number like number positions could be, but no, this is fine. Yeah. The thing that I might want to rename are these get all numbers. I would call it like I don't know, find get or something like that. Find all numbers, find number spans, for instance, because this not only gives you the numbers themselves, it gives you much more information, like where they are on the grid, and how many cells they span. So maybe get number spans or numbers info. Yeah, spans is fine, I guess. And let's call this thing also like number spans. Great. That is fine. I think I am okay with most of this code. I could extract these two things into like part 1 and part 2. let's see, this is basically part 1, and this would be part 2. Not like these comments add anything of value, but we then print, and then we say OK. Is part number is all right, I think. Maybe this add could be extracted. Like we could say first map, get all the neighbors of the XY cell on the grid, and then map each of those to we are going to have, well, nx and y, and say, okay, at these positions, and then this gives me just a byte, and we are going to ask if any of those bytes, and here we can replace this and say if the byte is not ASCII and is not a B. So yeah, that is also better, I think. If we run, we're still getting the same numbers, yes. Yeah, I guess this makes sense. And then get number spans, which iterates all the grid and finds the numbers. Let's take it. Oh, well, this also has this inlines add. We can replace that with the top level function add, which does the same thing basically. Well, instead of calling these nums, call them spans to be consistent with function name. Is there something that we could improve here? This is a bit kind of gnarly nested loop, mainly because we have this for the rows or for each line, but then we cannot do a for in here because we want to skip ahead. When we find the number, we want to skip ahead by its length. So yeah, that is that. And the way that we calculate the length, I'm almost sure that there's probably a better way of doing this. So okay, first we say if x plus num length is less than the line length, but this if and break is, I think, the same as if we put this here in the while condition, right? If we run again, yeah, it's the same. So okay, yeah. And the add is an accessor that is not doing well. It does bounce checking because Rust does that, but these things could panic if it's out of bounds. So we need to always make sure that our accesses are in bounds. It's not like I can just do add and early return if it was out of bounds or something like that. But yeah, this is already a bit better. I am wondering, let's add these changes for now. I am wondering if instead of having the number length, if it would make more sense to have the position for the end of the number. So basically, let's call it and x. Yeah, and while it's less than the length, the line length, so once index goes out of bounds, well, now if is it inclusive or not inclusive? That's also the thing. Otherwise, we would have to do less than line length minus 1. Maybe it's better to be inclusive. And well, in that case, it should start from x, not from 1. We increment and then we check. Yeah, we have to check if the next, so index plus 1 is an ASCII digit, then we include that one. Yeah. So we can probably pass this here. So we want to evaluate if index plus 1 is a good candidate for, well, if it's still a piece of number. So yeah, this makes sense. And here, when we are slicing, we have to go up to and including the end x. And well, the length, I could probably change what we are pushing here, but let's keep the code of what we were doing. So this would be minus x plus 1, if I'm not mistaken. And let's see if this still does the same. It does not. So I screwed something much less than before. So we are starting at x, we are adding 1. Okay. And we are taking from x up to including that x. And the length, so if it's the same number, x, and x and x, so it's a number of only 1, adding 1 should work. I'm wondering, where did I go wrong here? So with this, it was working, right? Yes. Where are we using this end x? Actually including. Oh, here we are incrementing this by index instead of by length. So we can just say x equals index plus 1 and keep going. So yeah, now we get the same thing. So is this code a bit more readable than what it was before? Well, I should also change, probably like the definition of this, the uses of this, so that it returns, what should it return? The position, so it will now be start x, end x, and the y, right? So I would like to say that start x, end x, and y. Yeah. Sure. And we have to see these uses. So here we have x index, or we can say x1, x2, and y. I don't know which would be start x or end x would be the most explicit names. So let's do that. And here we want to go from start x up to and including end x, and the rest is the same, so that's good. And this is for part 2. For part 1, we have also sort of the same here. So start x, end x, and then y, and well, we are going to pass the same things. So it's kind of like this, the span of the number. And there is no type error there because these are all uSizes, but they mean very different things. So you're gonna have start x, end x, and y. Y is still the same as before, but here we want to go from start x up to and including end x. Yeah, I sort of prefer this thing to doing x plus length. So it seems reasonable. The logic is basically the same. We are changing just whether we are using length or span from and to, but I think I prefer this. Let's take a look at the diff maybe. So xy length, yeah, it's kind of the same. Sorry if this is not very readable, and this is less readable. Was I looking at code at this size before? I don't even remember. But yeah, this sort of is a bit more consistent with start and end, I think. The end could also be non-inclusive, but that's fine. Because ranges on Rust are usually non-inclusive, but yeah. Open-ended, I think it's the correct word for that. But this is fine. Let's increase the font size. This is huge. I think this is fine. Okay, so yeah, let's leave it at that for at least this start and end x. I'm okay with this function now. Oh, I think though it's really merits a little comment of what it does or what it's returning. So finds all numbers on the grid and returns tuples of number with number start x and x and with the so find all numbers on the grid and returns tuples with the y coordinate and the x coordinate span of each number. Or let's say this where start x index is the span of the number on the grid, and y is its Okay. That last bit is not necessary to say. It should be pretty obvious. Yeah. Okay. And the last bit that we have is the neighbors function, which is a very important function on this problem. And what it receives does make sense. I do think, how much am I repeating this grid thing? Yeah, 4 times. Like all these functions are received in the grid, so I think it merits to be type aliased. So let's add a type alias for that. It's just grid. And then we are going to replace this with grids. And that's nice. Oh, but you don't like this because you need a lifetime? What? Really? Just for this? Well, I guess won't be needed for the uses, I think. Yeah, no, okay. All right. That's, I think, why I usually use yeah, if we had like managed owning containers, like a vector of vectors or something like that, you don't need a lifetime specifier for that, but that's fine. All of this is fine. These lifetime specifiers, I think, are needed because this iterator has to be bound to this grid, so that's fine. Now, this code is a bit too verbose for my likings. Like, neighbors function should be smaller, I think. So there's a couple of things that I think we could try. The first that I'm thinking of is this condition here. Well, this condition actually could be, I don't know why I'm using filter map here. We could say first filter, and it's this condition. Well, and then what is inside of this sum? So filter by this condition, and then map to this x, y, as you say. So this should, I think, be the same, but no. Oh yes. This should still be the same, I think. Yes, it is. And I think it's better than before. And this is a filter, right? So my cat's going crazy. So another way of doing this, of checking the bounds of this, is to do a conversion. Like if we do grid get y, so here we are first transforming the x, y, which are unsigned, to signed versions, so we can subtract 1 and not have an underflow. But then we have to transform them back to usize to access the grid. But if we do this, you know, if it was a negative value, there is no like bit conversion here, and by 2's complement, if it's a negative value, it will be a giant positive value when interpreted as usize. So this will be out of bounds for the underflow case. And then we can we could say what? And then, right? Or can I use short circuiting here? I think I probably could. I think, yeah. But the other thing is a string, so to be in bounds of the string, I think it's not so as bytes, but string doesn't have a get, right? Or what does string get? That is for so slice. Huh. This is the problem of having a grid defined as slices of strings. Like, well, but we can use as bytes here. That's the thing that we were using generally. So we can say the same thing with as bytes. X as usize. And if we only return from them both, I guess we can even do something like this. Filter map here. And go back to something, but we don't need all of this condition. Here we can say something like sum. Does this work? Yeah, now we don't dereference this. Well, it compares. Does it work though? Yes, it does. I think that's nice. That's pretty nice, actually. Yeah, let's add these changes. And now I'm also wondering if we could make this shorter. So the order of this seems a bit wacky because of how we implemented the first time, and then we had a bug here. So let's change it to how I think makes most sense. Yeah, kind of like this. We have first the x minus 1, and we go from y minus 1 to y plus 1, then the x, same x, and we don't have xy because, well, that is not a neighbor, it's the same tile. And then for x plus 1, this is just changing the order of the neighbors, should not change the result, it doesn't, okay. And I'm wondering if we could do something like, hey, replace all of these x's with nothing. So it just, well, here we need to say 0. And these pluses are not needed. And then replace all of these y's with 0, I guess. But 0 minus 1 doesn't make sense. Let's replace all of this with just minus 1. And 0 plus 1. Let's change it with nothing. So these are not the coordinates themselves. These are like the differences. So this would be dx dy, and which are type I32. Okay, and if we do let neighbor x neighbor y be there's a wrapping signed, I think. No, wrapping add. Yeah, wrapping add. But x and y are. I don't want these aliases. Wrapping add signed. Yes, if we add a sized variable, and then the same for y, wrapping at signed dy. This should give us back to what's your problem here? I'll leave the current function, but x. What is your problem? What is the type of this? It's an I size. And what is x? Oh, because x is an outer variable. Yeah, can we just move the things that you need? Yes, you can. Okay, great. And instead of x, y here, there should be nx and ny. And now these are already u-size, so they don't need to be. Oh, they don't need any of this. That looks better, but does it work? 0, 0. It doesn't work. Okay, I did screw up something. So these are I sizes. I means signed. And oh, I have my cat trying to eat some cables. Where did I screw it up? Oh, here. We are returning the same things. It should be nx and ny. That was a dumb mistake by me. Yeah. Okay, I think this is quite better. What happens if we extract this into a variable? Yeah, the thing doesn't want to collapse. This. It doesn't want to collapse this array, but it's fine. Let's leave it like this. So do I like this? Yes, I think I like it. It's more. It's much more explicit about that we want the wrapping behavior, and we don't have as many like as I size or as U size conversions. It's like we keep them as unsigned here by explicitly doing a wrapping addition, and this only these things that can be negative are signed. That's great. Yeah, and this is not too terrible either. If any of this fails, and then you return, yeah. I guess it's not so explicit like what we are checking. It's like this is the condition that we are checking. We could write this as a chain of get this and then get this and finally map to this, but yeah, this is shorter, I guess, and more direct. So let's actually see this diff. Yeah, it's not like it's much shorter or anything, but I do prefer to not having to do this first conversion to signed and then other conversions to unsigned back again. I think this is better, like more explicit. Okay. And I think that's it. I don't think there is much more that I want to change. I'm much happier with this neighbors function. This get number spans is better, I think, now with this explicit start x and end x. That's fine. Maybe it would be nice to convert this into something more readable. Actually, I think that there is a way that is simpler than this, right? We could say something like line starting at x, because we know that we are at x. Let's see the prefix. Strip prefix. And what does this do? Returns the string slice with the prefix removed. I sort of want a prefix. You know, like, hey, give me everything that matches this pattern. There's a match, right? So matches. Yeah, and I think this thing, yeah, you can pass things like char is numeric. That's kind of what we want, right? If we say char is ASCII digit, this would be the same as this, I think. Num slice be this. We don't like this because oh, wait, I'm not sure why it doesn't. Now here it's passing char is numeric right away, but what I want is actually like from this iterator, like this would be an iterator, right? So collect. Whoa, why is this thing not accepting the so I guess character is ASCII digits. Do you like that? What is here? Yeah, configure an closure parameter, explicit type. I really dislike sometimes that it seems like the Rust language server, Rust analyzer knows that this thing is a char, like can infer that properly, but for some reason the Rust compiler doesn't. Okay, and here we want the first match. Oh, but I think, wait, let's see the example. Yeah, I know, when it passes is numeric, it doesn't return, like it returns a separate digit, so it's not what we want now. It's like, there surely is some matching function for that, because it's like very obvious, but something like take y or something like that, but for slices. Isn't that like split? Split could be split. We would want to split when something is not numeric, but if it's on the end, okay, like I'm not really sure what I want. I will probably investigate off the record to see if there is a nice method or function for this. I'm pretty sure that there should be. Even like parse the number. Yeah, that could be also another alternative. Like, first of all, replace all the dots with spaces and then just parse numbers. Although it's it will probably not work for cases like this where there's some junk in the string. So not exactly, but not too different than what I want either. But yeah, reviewing the code again, going back to that, yeah, this is not the previous code, but I think it's good enough. Add is fine, is part number. Sure, we were checking if any neighbor, yeah, we're getting the bytes corresponding to those neighbors. Sure. How are we using these neighbors? Whoops. Screenshot capture. Actually, how are we using these neighbors functions? Yeah, I was thinking about their usages because here we are after getting the XY of each neighbor, then we are accessing the grid for that XY. But like the neighbors function could just give us that, you know, the byte and the X and the Y. Because it knows that after getting the thing, like this thing would give you the byte. Yeah, let's try to see. It will make this a bit more. But let's first add these changes, because so far I think that is all good. Let's try this as the last thing, last possible refactor. So if we have, let's say, returns the XY coordinates of the neighbor and the byte in that cell. So this would be a U8, and that makes this be multi-line, but okay. And then we should have some errors here. Here we are not accessing the grid, so we don't care about the byte. But here we we actually only care about the byte itself. So we could do something like this, X and Y, and remove this map, right? And I guess we do have, what's your problem here? Oh no, I confused the order of things. So it's X, Y, and the byte, yeah. And I think in the other use, I also confused the thing. So it's X, Y, and byte. Okay. And this is complaining now because there's an extra reference. So yeah, this is an unnecessary reference. And I think this is an alright change, because it makes sense that the neighbor gives you not only the coordinates, but also like what is in that coordinates. So yeah, we don't care about, we just care about what is in there. Great. And yeah, since we were already accessing the grid on the neighbors function, it makes sense to use whatever this get returns. So I don't see why not. Let's add this change and call it a day. Let's commit this. Refactor day 3 solution. And now more comments are necessary, I think. Like the changes are, I think, pretty obvious, most of the things we did. So okay, now this code is something that will let me sleep more soundly. And yeah, I actually kind of enjoy doing this sort of refactors after getting the actual answers. It's like, yeah, this is code that I could like feel good about if I were committing this into some job or something. So, and I want to learn like to program more or less decently in Rust. So yeah, it's always nice to do this kind of thing. So that's it for today's video, and if you have been, thanks for watching, and see you later, I guess. Bye bye.